Okay. So there are quite a few topics for today, as well as any topics from last time. So what questions do you have?
Can we just go over how to name something, like any one of them?
Okay, so today was naming alkanes. And then Friday's naming alkenes and alkynes. And then next week's naming everything else, which I've never done. Most books don't put naming all at the front. And let me just say up front about naming. It's all about following the rules. So that's why it's important. Plus somebody told me yesterday, they're like, oh, all those names that we didn't have to learn that I have to learn for the MCAT. And I reminded them that we did learn the names and that he's not going into the MCAT completely blind. So we need to name something. So let's start with this sheet. So the sheet I just gave you is on Canvas. This book does something that I haven't seen for a while, and that is that it does and that is that it gives you the options of using an IUPAC complex name and a common name. So basically, to name something, here's what I have to do. What I have to do is I have to find the longest continuous carbon chain in the molecule. That's my parent name. And then once I find that the longest continuous chain, that there are going to be groups off of that are called the substituent groups. Okay? They use this term locant, which I don't know what it means, but I use substituent. So if I gave you this molecule right here, I'll give you a couple seconds. Tell me what the number of carbons in the longest chain is. And you have to try all the possibilities. If I did it right, which is hard to say. Well, I didn't do it right, but that's okay. So what's the number of carbons in the longest chain? Give me a number. 9? Any other numbers? We all agreed that it's 9? Yes? Okay. Now, what is that 9 longest chain? If I start here, how should I go?
You can go straight across.
Okay. I'll go straight across. So there's 9 carbons in that chain. Is there another chain with 9 carbons? Yes. I'm going to duplicate this because otherwise there's going to be 50,000 colors. Well, there aren't going to be any colors. So what would the other 9 carbon chain be? Where should I start?
Start at the left instead of going straight across. The one with the little tail.
So, okay, so go this way, and then go like this?
Yeah.
Okay? I hadn't anticipated that one. Is there another one? Oh. So start at the bottom left here.
Go up.
Go up and then go right. Any others? Could I do the same thing and then go? Could I? Well, here we'll deal with this all at once. I could do this too, right? I hope that's it. So those are the nine. Those are the different ways I can identify 9 continuous carbon atoms. And so this molecule then, whatever it turns out to be, its final name is going to be nonane. The ANE means it's what? An alkane, and the NON means there's 9 carbons in that longest chain. Okay? Now let's deal with the 2 structures on the right in terms of the chain. So it turns out that at this branch point, I go 1, 2 carbons this way, and I go 1 and 2 carbons that way. Does it matter which way I go at that point? No, because it's the same group either way. If I was numbering, and I don't know this yet, but if I was numbering from right to left, I would start 1, 2, 3. There would be this group at carbon 3. If I started up here and went 1, 2, 3, there would still be the same group at carbon 3. So the fact is, when you have a branch point, you have the same 2 groups, it doesn't matter which way you go. So for the 2 structures or for the 2 longest chains on the right, it doesn't matter because they're going to be the same as the ones on the left. Does that make sense? We have to take this a little bit, we'll take this a little bit at a time. So if you're like, okay, I get that, there may be something else you didn't get. But if something doesn't make sense, you got to yell. So those 2 groups are the same. Now, when I'm looking at the pieces on the left, when I come to this point and go down this way, like I did over here, or if I go over here, those are not the same groups. And so there is a difference between going straight across on the left and going down on the left. If this methyl group wasn't here, they would be identically the same, but it is. So there is a difference in terms of the 2 starting points on the left. Everybody okay with that? Yes? All right. IUPAC rules. The IUPAC people who, I don't know, they live on a mountain somewhere, much like, I guess much like God, and they give the rules on stone tablets that they pass those down for people to use. Their ultimate goal is this. Everybody calls the molecule the same thing. Except for some language differences, a chemist in Russia, or whatever it is now, would call it the same name as a chemist in China, as a chemist in the US or Germany. The naming rules are the same. The naming rules have to give you one name. Okay? So the rule is that if you have more than one longest chain, the tiebreaker is we're going to use the longest chain that has the most substituents, that yields the most substituents. And what's a substituent? It's the group off the long chain. What I like to do is I like to circle it like this. If you have a highlighter, you could highlight the group, the longest chain, and then it makes it easier to see the groups that are hanging off of it. This is the way I like to do it. And so for the top one then, and we're right now not dealing with the ones on the right because they're going to have the same name. So we're just going to deal with the two on the left. How many substituents does the top chain give us, the one that goes straight across? It looks like it gives us 3 substituents. How many does... No. How many does the one on the bottom give us? Oh, good. We got 4. So we have this group, we've got this group, we've got this group, and we've got that group. I thought it was just going to be 3, and then I was going to have to consult the rules because I don't remember the rules past the greatest number of substituents. There is another rule if you have the same number of substituents. If I do that on a test, you get credit for either one because I don't expect you to know the rules that much. I do expect you to remember this. So I've got 4 groups versus 3 groups. We're working off the bottom one. Okay, that's the correct longest chain. Right. So longest chains don't have, there's no rhyme or reason to them. They can go left to right, they can go up and down, they can go zigzag. You're looking for the longest chain. So that's the first thing you have to do, and sometimes you'll find more than one. So this is what happens if you find more than one. We break the tie by using the structure with the most substituents. Okay. So let me go ahead and erase the check marks. So now what I like to do is I like to name the substituents. And I think in the textbook what I suggested was that when you're first starting out, like if I said, okay, what's this group right here? What's the name of it?
Ethyl.
That's an ethyl group. It's a 2-carbon group. Now, what I would suggest to people if they first start and they can't do that quickly in their head is let's expand the structure. So when we expand the structure, every intersection, every end of a line is a carbon. We add enough hydrogens to give 4 and only 4 bonds. So that means this was a carbon with 2 bonds, it gets 2 hydrogens. So that's a CH2, CH3, 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 CH2, CH3. So I suggest doing that initially until you begin to see what the structures look like. Okay. And that'll be important when we get to some of the more branched chains like isopropyl or sec-butyl, or even like a terphenyl. Okay. So now let's name them. So this was ethyl. What's this one? Methyl, just shout it out. Methyl, this one. Methyl, and this one, ethyl. These are pretty boring. I'll see if I can make up one with a little bit more complicated structure. All right, so I've got ethyls and methyls. We'll have to deal with that in a moment. But now let's do numbering. So first step, longest chain. Second step, name the groups. Name the substituent groups. Third step, numbering. So the rule is you're going to number from the end closest to the first substituent. So if I start from the left, my first substituent is at carbon 2. If I start from the right, my first substituent is carbon 3. So that means I have to number from left to right. Okay? Because I'm numbering from the end closest to the first substituent. And I added in the book what happens if there's a tie that way. What would happen if there was a group at 2 on the right-hand side? Well, 2 groups versus 1 group, 2 groups wins. 1 group versus 1 group, we use alphabetization to break the tie. And that's why I like to name the groups first, because I'm going to need the names probably to break the ties in the numbering scheme. So I might as well have the names out. So if there was an ethyl group at carbon 2, it would be methyl versus ethyl. Ethyl would win. If they're both the same, we've got a tie. We move to the next substituent. 2 substituents versus 1, 2 wins. Otherwise, we go alphabetization. And we keep doing that until we find the point of difference. And if there is no point of difference, then it doesn't matter which way I number it. I can go left to right or right to left, or up or down, or whatever the numbering scheme is. Everybody still with me? I don't see anybody's head on the desk yet. So, I'm going to erase these numbers. And now, I like to write the numbers all the way across. What I find is, after grading thousands of these naming problems through the years, you want to make sure you get all the numbers in place. Because if people were to make a mistake, most likely it would be that they miss a number. Okay. All right, so everybody with me? Okay, so now what we do is we name. We take the names and we take the numbers, and we're going to put that in front of non-name. So the whole idea of this name is that when I look at it, I see, oh, it's non-name. I'm going to draw a 9-carbon chain, all single bonded. And then for each substituent, I'm going to know what the substituent is and what number carbon it's at. So if I'm just tallying these up, what do I have? I have a 2-methyl. I've got a 3-ethyl. I've got a 3-methyl. And what? A 7-ethyl. So there are my 4 substituents. Now when 2 substituents, when there's 2 or more of the same substituent, we now condense those down. Instead of saying 2-methyl, 3-methyl, I'm going to condense this down, and I'm going to say that there is a 2,3-dimethyl. Okay? The prefix that comes in front of the methyl is di, tri, tetra, penta, hexa, hepta. Not septa. Hepta, octa, nona, deca. After that, that's too many. So that tells us that there are 2 methyls at carbons 2 and 3. Now another mistake that people will make initially is they will have 2 numbers but only 1 or they'll either have two numbers without the di, or they will have the dimethyl and only have one number. There needs to be two numbers, even if the number is the same. Okay. Because when I'm reading through and I see a 2-dimethyl, I'm like, okay, one methyl goes at 2, but where's the other one go? And any ambiguity in the name, where I would write it differently than you would, the name's wrong. The name's got to tell us exactly what molecule to write. And there can only be one name. So what would I do? The ethyls, I do the same thing. I would say there is a 3,7-diethyl. And so any groups that are the same, we're going to combine them up. So there's my dimethyl and my diethyl. So now I'm going to write, now I've got all my substituents together, I'm going to create an alphabetized list of substituents before the nonane. So in this case, ethyl comes before methyl. Dis and tris are not used in alphabetization yet. There's a special circumstance where they are. This isn't it. So my name would be 3,7-diethyl 2,3-dimethyl nonane would be the name of that molecule. And if we get really specific about commas and dashes, which I tend not to be, but the book, any computer grading might be, there's a comma between the numbers and a dash between the numbers and the letters. And then the dimethyl nonane should probably be all one word. But as you're doing example problems where they give you the names, you'll see what the exactly how it's done in there. If I'm asking you to write this on an exam, whether there's a space between the L and the N is irrelevant. So does that help with the steps? So then we can make it more complicated by putting in more complicated groups. Methyl and ethyl are as easy as it gets. The groups that you have to know, and notice I use the word know instead of memorize, because memorize is bad, but you have to learn these. So whatever term you want to use are all the ones that are kind of in the gray. So what happened was, for complex substituents, a complex substituent is one that doesn't have a common name. And there's two forms. This one doesn't really get into the name of how we came up with common names. Common names pretty much, I discover this group, I name it. And then if everybody accepts my name, it becomes a common name. Well, that only goes so far. And so the idea of the secondary butyl group was that in the common name system, we always are looking at the total numbers of carbons that are in the group. So if there's 4 carbons, it's a butyl group. What kind of butyl group? Well, there's different kinds of butyl groups. Anything that's a straight chained alkyl group is just given the name. So propyl butyl, pentyl, hexyl, those all mean straight chained alkyl groups as substituents. Did the book, I can't remember if the book had the N in front of it, like N-butyl. So N would stand for normal. So if you had a propyl group that looked like this, you could either call it N-propyl or you could just call it propyl. The N's fallen out of fashion. It fell out of fashion like 10 years ago. It fell out of fashion with me when I wrote a paper that had this molecule called N-butyl lithium, and I kept calling it N-butyl lithium, and the referees like, you need to learn your IUPAC language because you don't use N anymore. That's like saying the. So I'm like, I'm not going to argue with them. I'll just erase all the N's and we'll be done with it. So N-propyl or propyl's fine. You don't alphabetize N. Anything that has a hyphen is not alphabetized. So this one right here is, and I'll give you kind of an insight in terms how we do the common names, because there is a system. This is total carbons is 4 butyl. This is the butyl group that has the connection to the secondary carbon. And what are primary, secondary, tertiary, and quaternary carbons? That just tells you that's the carbon, how many other carbons are attached to it. So in this structure, as it stands now, with the empty bond, because the empty bond's where it's attached to the chain, that carbon is secondary. So this becomes a sec-butyl group. That's actually the system. I mean, common names are supposed to not have a system, but they do. So that's the butyl group where the attachment is to the secondary carbon. They just gave you, I think, the whole list in the book. There's another sheet and there's another handout in Canvas where I believe that I went through and circled like the iso group and the sec and kind of went through the system. So let's just go back. So here's a propyl group. Here is a propyl group. Here's a second propyl group. What is it called? Well, now you're going to probably want to call it sec-propyl. No, there's no such thing. Whenever you have a CH attached to two CH3 groups, this entire group is what we call the iso group. Now again, this is common name. So anytime you have a common named group with an iso group, it's going to be iso whatever the total number of carbons is. For instance, if I add a carbon to this and say, here's my CH2, CH, CH3, CH3, that has the iso group in it. It's a total of 4 carbons. And so this becomes the iso-butyl group. And then if I had another carbon in front of that CH2, it would be isopropyl. All of those are on this handout. So it goes from isopropyl, it assumes all the N's, so N-propyl, N-butyl, N-hexyl. Isopropyl, isobutyl, sec-butyl, tertiary-butyl. What would a tertiary butyl group look like? A tertiary butyl group would have it would be a butyl group where the attachment point where the attachment point is a tertiary carbon. This again. So in this case, this is a tertiary butyl group. So there is a system that we use for common names. All right, everybody okay? Now, what happens if it doesn't have a common name? What happens if this group doesn't fit one of these? I'll give you an example. I'll give you two examples. Let's say I have a 5-carbon chain I have a 5-carbon chain, and there's 2 attachment points within the center of the chain. And remember, these are the alkyl groups that are attached to a long chain. So I need to know these names in order to name the substituents that are going to come before the parent name. So that's what's attached down here, is the longest chain. Now, common name system breaks down here, because the common name system still has to be unique. So if I wanted to call these two sec-pentals, which one am I talking about? Because they're both pentyl groups attached to a secondary carbon. They're both pentyl groups attached to a carbon that's attached to 2 other carbons. So I can't say sec-pentyl, because sec-pentyl would not be unique. Some people might write the one on the left, some people might write the one on the right. So that's where the IUPAC rules break down, or at least the common names. So then we have another naming system. So how would I name these? Do you remember from the... So first step is I'm going to name these alkyl groups using kind of the same rules I used to name the alkane. Except they're actually a little bit easier. Because in this rule, where they're attached is automatically carbon 1. So the attachment point, number 1. Automatically number 1. Then we find the longest chain. So we can either go left or right. We find the longest chain in this alkyl group. So the longest chain here is 4 carbons. The longest chain on the one on the right is, it's going to be 3 carbons, and it doesn't matter whether I go this way 3 carbons or whether I go to the left 3 carbons. So I could identify the 3 carbons, the center carbon, which is automatically number 1, the 2 carbons to the right, or the 2 carbons to the left. It doesn't matter because what's left over is the same. The one on the left, I have to go with the 4 carbons because otherwise it would just be 2. All right, so we number. At the attachment point, we find the longest chain. Now I'm going to name this exactly the same way as I just named my alkane. Except it's not an alkane, it's an alkyl group. So this group then is a butyl group, because it's 4 carbons in the alkyl group make it a butyl group. This one over here is a propyl group. Either way, if I name it going to the left or if I numbered it to the left or to the right. Now, what's attached to that butyl group on the one on the left? There is a methyl group at carbon 1. So this is a 1-methyl butyl group. So after I've identified the connection as carbon 1 and found the longest chain, I'm now going to look at the substituents of the substituent, and I'm going to name and number those. And they come in front of the longest alkyl group chain. So this is a 1-methyl-butyl. What would the structure on the right be? It would be 1-ethyl-propyl. Everybody okay with that? Was everybody okay with that coming in? Are we like super bored because all I'm doing is reinforcing what you know? I'd be happy if that was the case for everybody, but if there's one person who's like, okay, this is helping, I guess I'm doing my job.
Why don't you include method? Where do we have
So here's my longest chain. What's attached to it? This group. And what kind of group is that? It's a CH2CH3 group, so it's an ethyl group. So what we would do is we do the same thing. The numbering scheme is automatically set up for us. You start at the connection point and you find the longest chain from that connection point. You have to start at the connection point. Okay? So you can't go any farther. So it's always starting at the connection point. Then what's attached to that group then? Here it's an ethyl group, here it's a methyl group. And we'll do one more a little more complicated. Now, remember that these are substituents that are attached to a long chain that may have other things attached to it. So the rule is I need to put that group in brackets, because what's going to come in front of that group is a number. The number where that group is attached to the longest chain in the alkane. Because we're just dealing with a little piece of the alkane here. Right? So this is just one group in the alkane. So if I put it in brackets, then I don't get the numbers messed up. So this would tell me that a 1-methyl-butyl group is attached to carbon 4 of a nonane, for instance, or a decane, or a unidecane, which I believe is 11. So everything is in the brackets. Still with me? Because if you're not, you gotta say, whoa, hold on. Right. Last thing about brackets. The first letter in the bracket is alphabetized. Whenever you have parentheses or brackets, it's the first letter that's in there is what you use to alphabetize your group.
Just so I make sure I'm clear. These are attached to a parent group somewhere.
Yes. Yes, they are attached to a parent group somewhere. Where cyclohexanes were in this too, right? So they could be attached to a cyclohexane molecule. And so then it would be something cyclohexane. And if we have to go back to cyclohexanes on Friday, we can do that as well. But I want to make sure everybody's here. So,
What did you mean by the
so if I have, let's do this, let's say I've got this. I've got a CH3 and then down here I've got a CH with a CH2, CH3 with a CH2, CH3. So I'm going to switch it to cyclohexanes because if I try and draw a long chain and put one of these groups in it, that group has to be, the chain has to be longer than the groups so that there's no issue of, it becomes part of the chain. So let's just do this one. So if I had this one, this is a methyl group, and we've now said that this is a 1-ethyl propyl group. So the question in naming this is it 1-methyl, 2-1-ethyl propyl, or is it 1-ethyl propyl, or is it 2-methyl? In cyclohexanes, you have to find the lowest sum of the substituent numbers first. That's either making this one number 1 or this one number 2 or this one number 1 or this one number 2, because they both add up to 3. But now to break the tie of where I start numbering, I have to use alphabetization. So they have to say, okay, which one of these two groups is alphabetized first? It will be which one? The ethyl propyl. So this would be number 1, this would be number 2. So the name of this would be 1,1-ethyl propyl, 2-methyl cyclohexane. So that's what I mean, yes. When we're naming complex substituents don't have a common name. Complex substituents go in brackets. Then there has to be a number outside of that bracket to tell you where you're putting that group. In the cyclohexane or in the long chain. But the key is alphabetization-wise, in brackets, it's the first letter. Okay with that? What if the first letter is di, or tri, or tetra? Yes, that rule still holds. So if you caught a while ago when I said you never alphabetize on di or tri or tetra, and I kind of said right now, if the di or tri or tetra is in brackets, the rule is first letter period in brackets. So whatever the first letter is, that's what you alphabetize on. And di or tri, you alphabetize on those because they're in brackets. So that's the exception to the di or tri rule.
How did the 1-ethyl propyl again?
So this was the structure. If I did it down here, I would say let's start numbering at the connection point. Let's now find the longest chain. So that would be 3 carbons. What's attached to that 3-carbon chain? An ethyl group. And so this is a propyl group. with an ethyl group attached at 1 ethyl propyl in parentheses.
What if it was a one method propyl?
If it was a 1 methyl propyl, good question. So if it's a 1 methyl propyl group, which comes first, methyl propyl or methyl? In alphabetization rules, it would be methyl. It would be like if I had to alphabetize Smith and I don't know, Smithy. Right? The Smith would come first, and then the Smithy would come second because it's got extra stuff after the Smith. So methyl would come first, then the methyl propyl would come second in the alphabetization rules. So we're kind of okay, maybe, until we actually have to do some. Now, last thing. So, the book uses these rules to come up with sort of what I would have considered a few years ago IUPAC names of the common names. So they would, for instance, called a Sept-butyl group a Sept-butyl group, but then they also said, oh, this Sept-butyl group could be a 1 methyl propyl group. Right? And this terch-butyl group, oh, beautiful. That terch-butyl group, starting number 1, the longest chain would be 2. So that is a 1,1-dimethyl ethyl group. If we use those IUPAC rules to name the common name. We had a book that did this years and years and years ago. And it drove me up the wall because then they actually didn't use the common names. All terch-butyl groups were 1,1-dimethyl ethyl groups. And all isopropyl groups were 1-methyl ethyl. Right? Now I can do that in my head because I've been doing this a long time. Every day it seems longer and longer. But we usually talk about terch-butyl groups and isobutyl groups. We use the common name. So what IUPAC did, I don't know when, they did it years ago, they just said, you know what, we cannot have people naming a terch-butyl group as a 1,1-dimethyl ethyl group, and some other people are calling it a terch-butyl group. Because think about what that does to the numbering scheme sometimes. Because it's going to change the numbering scheme. So a molecule that has multiple of these groups could have like 4 different names. And there was a time when I actually accepted all 4 different names. Because I gave you the choice. But then IUPAC said, no, we're done. We're going to accept these groups as common names that are now IUPAC. So there is no 1,1-dimethyl ethyl group anymore. It's always terch-butyl. And the reason they did that is because their goal is to come up with a system that gives you one name for the molecule, one and only one. So that's why you need to know these common names, because they're IUPAC names in this system of brackets no longer exist. So that's kind of that's the basics there. We're going to be doing these same rules, longest chain, how do you number it, how do you write the name. We're going to be doing this for the next three days. So if you have questions about anything, write them on the cards. If something came up here, you can give it to me, but otherwise bring them on Friday. I'll quickly go through them. I'll start answering questions, hopefully not elaborating into a mini lecture, but if necessary. And then I'll finish up any questions that you have and put them on the discussion board. Right. So the next couple sections in chapter 2 is what we can talk about on Thursday. We can also, or Friday. We can also talk about this as well.